Hello all. In this video, we'll be discussing a Python-based machine learning model to predict the price of a house on the given features. So let's have a look on the code and let's deep dive into the domain of machine learning to see what it creates. Initially, we are using a Bangalore house data.csv file. This is a data set here, which contains the features like area type, availability, location, size, society, total square feet, bath, balcony, price, etc. So through this particular data set, we'll train our model and accordingly we'll test it. So initially we have implemented all the necessary libraries included to build this model, basically matplotlib, numpy, pandas, and this particular matplotlib .rc params is a function that set up the figure size as 20 comma 10. So as you can see, this is used to customize a matplotlib at runtime. All the figures and plots will be 20 inches in width and 10 inches in height. This particular function helps us to standardize a figure size throughout our code or model. So throughout our model, all the plots we will use to visualize our dataset will be of this standard size, that is 20 inches in width and 10 inches in height. So we have loaded our dataset. As you can see that we have loaded our dataset in Visual Studio Code. So this is basically, we have checked the shape of our dataset, that, and specifically we have checked the shape of our dataset through area type column in this. Secondly, we have cleaned our dataset. For example, there is a lot of value in a dataset there that is of no use. So we need to clean our dataset first. So we have dropped some values. We have checked that whether the values are dropped or not through isNull function. We have created different data frames as df1, df2, df3, and as per the improvement and the cleanliness of data, we have created new data frames and moved ahead in this model building process. So we have checked that this particular data frame is free of null values. That's why it is returning false in every cell. Next is df.isNull.sum. Still, we have some necessary values in this data frame. As you can see that we have cleaned this data set also. So we have dropped some values, we have cleaned the dataset. This entire process is a dataset cleaning process. So we have cleaned the dataset first. Now all the null values are dropped. We have a clean dataset in our hand. It's time to go ahead with further operations in the dataset. Now we have checked the dataset. We are currently with the data frame of .shape function. So this is our shape function. Now we have used a lambda keyword, basically lambda function, which is an anonymous function in Python. This we created a new column named as bhk and only taken the numerical part of the string from the column of size. Through this particular code applet, we have taken only this numerical part of bhk through this data set. We have created a new column as bhk, and through we can have a look that through size column of our data set, we have split the data set. We have split this particular column, and in this bhk column, only the numerical part of string column has been saved. So we have printed a data set. As you can see that bhk is a new column we have created. So as we have created a new column as named as bhk, we have taken the values from size column. As I have mentioned, these are all the markdown and comments I have added to make the code more understandable enough. Then we have checked some unique values in the bhk column. Then we have checked that in bhk column there are, if the values are of greater than 20, we have looked into that. We have explored that particular data value. We have explored total square feet functions or total square feet column also. Basically, we are exploring column by column and we are seeing that which column would be the best suited to move ahead with the further operations and move ahead with the further model building process. Basically, now we have checked the value counts. So this is basically this particular function is a function which check that whether the value is in float or not. If the value is in float, then it converts it to the float, else it returns false. So we have in the total square feet function, we have apply the isFloat function through apply keyword. And as you can see that in total square feet functions, all the float values have been changed into somewhat range values. So this is a plus point that we can take some numerical values and train a data set accordingly. The next we have converted square feet into number. As you can see that this particular square feet has been converted into an exactly float values, exactly decimal values, so that float values can be dropped from our data set. This particular code applet is used to convert the total square feet column values into a proper decimal values. Then through log function, we have checked that again you can see that a new data frame has been created, df4, as you can see that. So we have created n number of data frames, and we have implemented some more operations so that we can move ahead with the further process in the data set. The next we have printed the head. See, the basically the process is going on like this, that we are uh, creating a data frame first. We are then implementing some various functions and various operations according to our own logic and syntax of Python. Then we are creating a new data frame. Then on this new data frame created, we are operating more functions, and through this way, by creating new data frame and by implementing each and every functionality to achieve the machine learning building process, we are creating a new data frame, and we are moving ahead with further operations by creating new data frames. So now again we have copied the data frame in the in the df5 functions, and now after on df5 function we'll implement all the functions right here. So as you can see that we have checked the unique values, we have checked the length of unique values. The next is somewhat the we have used group by function to sort values so that the data set looks somewhat stable, and we have aggregated through agg function in Python. The next we have again we have checked the len of each and every column, and we have grouped by each and every column through in df5 data frame. The next we have applied df5.head. As you can see that after the 5 data frames have been created, after df5.head, our data set looks somewhat like this, that all the values are converted into proper decimal values, and the values needs to be in certain range has been converted. As for example, price per square feet has been converted into a float, so we can move ahead with further operations. The next is the process of outlier detection. So this particular phase of machine learning process, which is outlier detection, contains we need some sort of domain knowledge out here to remove the outliers. So as you can see that if total square feet value cannot cross greater than 300, so we have applied this particular logic to remove the outliers. For example, if a data set or data points contain some of the values of bhk which is greater than 300, so this particular code output will automatically drop that particular value and remove that particular value and will return the data set from the removed values. Then again we have checked the data frame shape. As you can see that df5.shape function gives this particular value, and df6 is not this data set. And with df5, and now we have compared that df5.shape and df6.shape. As you can see that in df5.shape there are 1 3 2 4 6 rows and 7 columns, and in df6.shape, after the cleaning process, after all these values have been removed, now the dataset shape reduces to 12502, 7. So as you can see that we have cleaned the dataset further. Basically cleaning a dataset is one of the most important process in machine learning building process, as the more we clean our data, the more efficient results will model predict, and the model will perform more efficiently and accurately. The next we have again setting a threshold, considering only that values which will be greater than mean minus standard deviation and smaller than mean plus standard deviation. Basically, this is also a concept of domain knowledge, that we'll set a threshold value on a data set, and we'll only fetch that values which will be greater than mean minus standard deviation and smaller than mean plus standard deviation. So this particular code applet gives us this values, and now the shape of the dataset is reduced further. As you can see the difference, that here it is 12502, 7, and here it is 10241, 7. Now again we have created a new data frame as df7. Now until now the 7 data frames have been created, and after creating 7 data frames and after implementing some more functions on it, we have come out to be we have created a data set which somewhat looks like this. Next, this is time to visualize a data set. Basically, a scatter plot is created of price on y-axis and total square feet area on x-axis. So as you can see that this particular code applet helps us to create a scatter plot to visualize our data further, so that the data could be visualized through graphs and scatter plots, and some insights could be came out. Next, we have printed the head of the data set. Then again, we have from this through on this data frame dot df7, we will remove some more outliers out here. So as you can see that now our data frame is reduced to 7,329 values from a 7. So basically again we have cleaned the data set, and from the entries like this, from the entries and values like df6 like this, we have decreased the data set and cleaned the data set, and now the shape of the data set comes out to be 7329, 7. Now specifically we have plotted a scatter chart for Rajaji Nagar column. As you can see that, as far as the values on in Rajaji Nagar is concerned, it somewhat look like this: total square feet area and price in Indian lakh rupees. So you can further plot for Indra Nagar and etc. on all the values that is given in the data set, and you can further analyze it. The next, we have created some of normal distribution, which have price per square feet in on x-axis and count on y-axis. This basically count tells us how many values lies in this particular range. So as you can see that mostly houses are of 5,000 square feet. So the number of houses that are mostly that is maximum in it is of 5,000 square feet. So again, we have implemented some unique and a group by and aggregation functions on df8 data frame 8, that is 8th data frame. Then next, in this particular data frame, we have created some visualizations again. Now we have checked that again we have after implementing all the necessary operations on 8th data frame, we have created a new data frame, that is 9th data frame, to move ahead with the further operations. As you can see that now further we have cleaned the data set accordingly, and now the entries reduces to be 7,251, 7. Again, now dropping all the necessary columns for training and testing process, we have basically created a now the model is fit for going into a train test split phase. So as you can see that this particular, again we have created some more data frames, and now we have visualized the data set continuously as 11th data frame, 12th data frame. And as you can see that this particular now our data set is ready. We have training and testing variables. Now finally df12 is our data set which we have fetched through performing all the necessary operations on the data frame. And now 12th data frame comes out to be the best suited clean data set after removing all the outliers and after sorting and group buying all the variables accordingly, so that we can achieve the maximum results and efficient algorithms. So now the model is ready for the trend test split phase. So again through SQL module we have imported the train test split phase, and we have trained a dataset with a test size of 0.2%, as I mentioned earlier, which is 20% of data will be 20. This test size equals to 0.2 means 20% of data will be using for testing purpose. Yes. So now we have imported through SQL module we have imported linear regression algorithm, and through this fit function we have fitted this LRCLF is our linear regression classifier. We have implemented this fit function. We have trained a data set further, and now which algorithm is the score of this algorithm is 84%. Basically, this particular code aptitude gives out to the score of this algorithm. So that now we using k-fold cross validation out here, we'll check that which algorithm is best suited for this data set. So further, as you can see that this k-fold cross validation is used to check the scores of each and every algorithm. Firstly we have calculated the score of linear regression algorithm, which comes out to be 0.84, means 84%. The score of this algorithm is 84%, which is quite decent. Using k-fold cross validation, this is a technique which allows us to decide which machine learning algorithm would be the best for our dataset. So through this particular k-fold cross validation technique, we can check the performance and the score of each and every algorithm available in the module. And this particular k-fold cross-validation techniques judges our dataset and tells us which algorithm would be the best suited for algorithm for our dataset, so that this particular model can be trained through the most efficient algorithm, so that we can get the maximum and efficient and accurate results. So as you can see, this returns an array with the scores of each and every algorithm specifically. So we have created a grid search CV, and on this grid search CV, we have called this particular function of through which it will create return a somewhat this kind of output, where we can see that linear regression model is of best score is 81%, lasso algorithm is 68%, and decision tree is 72%. So as you can see that the best score comes out to be of linear regression algorithm. So we'll opt for linear regression algorithm, and we'll move ahead further with linear regression algorithm. Basically this basically this grid search CV and k-fold cross validation is the concepts and techniques in Python which helps us to select the best algorithm which fits a dataset to achieve maximum accurate and efficient precise results. So next we have this particular columns x dot columns which we have in x. So this particular contains all the columns, that is total square feet, bath, BHK, first block Jayanagar, JP Nagar, first block, first phase JP Nagar, etc. So as you can see that we have created now a predict price function on which the model will predict the values accordingly, and we have predicted some of the values of, and this particular predict price function will take the parameters as location, square feet, bath, BHK, etc. So yet again we can see that we have predicted the prices of some function, and now it's time to predict some of the price of price of a house, giving the parameters as location, square feet, bath, BHK. So we have called the predict price function out here. We have give the location as first phase JP Nagar in Bangalore, square feet as 1000 square feet, number of bathrooms as two numbers of bathroom, BHK as 2 BHK. So as you can see, this particular function here comes out to be BHK, and here is bath. Here is, you can see that square feet, number of bathrooms, and BHK. So basically we have given all the necessary parameters which will be needed for predict price function to give out the range of price of house. So as you can see that in Bangalore, in the area of first phase JP Nagar, with a square feet of 1000 square feet, with a BHK size of 2 BHK and the number of bathrooms as 2, the price of house comes out to be 83.4%. The price of house comes out to be this particular figure. And the second, we have predicted the in Bangalore, if the location is, as you can see, we'll map each and every variable of this function. In Bangalore, if the location is Indiranagar, square feet size as 1000 square feet, bath as 2, and BHK as 2. So this particular function will give this predicted price of this amount. So the house in this locality with 1000 square feet, 2 BHK and 2 bathrooms comes out to be this much. So this is basically an entire machine learning model where we use grid search CV, k-fold cross validation, various scatter plots, histograms, normal distributions to visualize a dataset, to analyze a dataset, and grid search CV and k-fold cross validation were used to select the best fit algorithm for a dataset, which could predict the price of a house on the basis of features like square feet, location, BHK, bath, etc. So thank you so much for watching. Please do subscribe to the channel My Project Ideas. I hope the code is precise and clear enough. And till now, I think the things are clear and precise. So please do subscribe to our channel My Project Ideas. Until keep growing and keep exploring, keep growing, keep coding, and keep exploring.